Okay, all set. Okay, okay. Okay. Let's get back to the slide. Okay, we pull the data from many data source like app and sensor and aggregate all the data to the data factory or to orchestrate the data source and sensor device and so on. And one more thing that we can control the queue of data by using the event hub. And then we store the data like in the data lake store and like a structured data like a SQL data warehouse. And this is a very important part as we use measuring and analytics to make a model and predict for the data and detect and of to detect anomaly, and we can apply the machine learning model to be the application in the like a chatbot or like a cognitive service. The cognitive service you will get you will get the more information from usual on tomorrow, and and the most of thing that should they should have some dashboard visualization used by using the Power BI there, and so the user can use the intelligence app there and visualization by using on the dashboard over here. Okay, so next, in the machine learning on the cloud, there are many stacks that each people can use on the each stack. Like uh, the first thing that is very important is a machine learning algorithm. This is very important part since we should understand how to use the algorithm, how we can apply the algorithm based on the each type of the data set. And the next one is a machine learning model. I mean, to make a modeling via the Azure Machine Learning Studio. This one is very useful for data scientists to build some model and make the prediction over here. And once data scientists have done for the modeling, so we can make a like an infrastructure to reproduce the prediction solution by using the web service over here. And if you don't have any idea for the machine learning, but you need to make a intelligence app, you can use the cognitive service. It looks like an instant algorithm that you just develop your application and connect over here like a API over here. Okay, so okay, I have to go deep dive a little bit. That will be the data science process. So how we can craft the data science process. So let's see at the objective from the dataset, and once we have done on this step, so we can make a pre-processing. Pre-processing looks like we clean the data. We build some well prepared data before we train the data. Once we done this, we can split for training data and testing data, and score the model to test about the algorithm performance and evaluate model. Once we have done this, so we can deploy the algorithm as our API and so on. Okay, so next one is about the machine learning algorithm over here. So what we should understand is about this, because we can use many views of the algorithm. Like first thing, we can use custom algorithm that written in the R or Python, or you can use a ready ML services from the data market, use an existing algorithm. And okay, we have some guideline to show you that if you do something like, for example, we need to do like a classification. There is a guideline to show how we can use algorithm in each view. Like for example, to gain more accuracy and fast training, you can use two-class decision forest. And if you want to use multi-class classification to classify two more things and so on, if you want to gain more accuracy, fast training as well, so you can use multi-class decision forest. If you need to predict in terms of how much we can sell in next 3 months, in next 6 months, so we can use regression algorithm over here. And if we need to cluster the data to cluster the similar group in the same group, we can use the k-mean algorithm over here. It's pretty complicated for the beginner, as I know, but to understand this, so I need to clarify something over here first. But I have a summarize on over here. So if you want to answer yes no question, you can use a classification algorithm. If you want to predict a numerical value, just use a regression. If you want to use group data in similar observation, just use clustering. And for the recommendation, we have a recommendation system over the Azure as well. And if you need to find anomaly in the group, so you can use anomaly detection over here. Then there are many other ML algorithms for specific problem as well. Okay, so let's get back to the tool for the machine learning by using the Azure. First, I would like to present about the Azure machine learning. Azure machine learning we can is look like that we can use historical data and pull the historical data to test the model type. The interface of machine learning, I mean that Azure machine learning looks like we can drag and drop and just create a studio, so we can start to build a machine learning model over here. And next, once we certify about the algorithm, I mean in terms of performance, so we can deploy it as a web service, and then the developer can develop some application to connect the machine learning API over here. At the same time, for the business analysts who want to take a look about the insight under the machine learning algorithm, so the business analyst can craft the visualization by using the Power BI and connect over the machine learning API over here. That's it. Okay, I have some demo to show you to clarify and get better understanding for the machine learning and how we can develop the application and connect to the machine learning model. Okay, the first thing is about the customer churn analysis. This is very good for the P&G, I think, since we can predict about the churn, analyze customer churn to find the risk data point, and we can analyze if there is some risk in each area and in different geography over here. Okay, so how we can do that? The first thing, we pull the data stream from the database and so on. And we put by using the Event Hub, and Event Hub will manage for the queuing message and stream the data to data warehouse and send something in the machine learning to predict about the search analysis. And then we the prediction result will store in the Azure block storage and show the results on the Power BI dashboard. So let's see about the demo. The demo over here. Okay, this is a final product for the dashboard, so we can visualize and take a look for the risk data point if there is some churn for the customer, and we can select for different geography, like in Alaska. Oh, sorry, I have to refresh. Okay, here we go. Okay, so we can take a look if there is some risk over here, and we can drill down to the churn rate in each geography. Like this is like in the different geography over here, and we can drill down the the risk analysis in different geography, and we can take a look for sales overview over here as well. So this is very useful and powerful to keep a relationship to the customer, and we can build the cool stuff to the customer to keep the good relationship with us to continue for the selling in the future. This is one powerful tool to use by applying the machine learning model over here. So behind the scene of this application, okay, this is Azure machine learning. So we can use historical data to pull from the various data source like a web, from the big data like a Hadoop, like a SQL database, and so on. So, and then we can make a pre-processing, and then we can train the model. We can use the instant model from the Azure machine learning model. And once we certify about the experiment, so we can evaluate the model for the accuracy. So it's so easy to use. Just right click and visualize about the model performance. So we can see that there's a pretty good, pretty good accuracy as of now. Is about 87%, and precision is not too bad. It's about 89%. And then once I pretend once this is a good model, so we can we can make it ready to deploy by making a predictive experiment. It means that I'm working for the web service workflow over here. So you can see that there is some web service input over here, and this is a well prepared model over here. So once we done this, so we can deploy as a web service. So let's see. This is a web service. This is very similar way to deploy a web service. You can see that there are a lot of parameters over here. So I think developer can understand easily this once they need to develop the application and connect the machine learning API over here. You can see this. You can see the sample request by this is a JSON format and response and the parameter type of parameter over here and sample code. This is very easy for the developer to understand how they can develop the application and connect to the machine learning model API over here. Okay, this one is one of example I want to show you, and the next example is about handwriting recognition. Okay, last example is structured data, but if we need to handle about how unstructured data, how we can do that. So okay, so this is unstructured structured data, like this is an image data set. Okay, I need to make a handwriting recognition by recognize the number from 0 to 9. Okay, so and I will have some application to support the user to write the number and let it recognize what the number user write down over there. Okay, so let's see how can I do that. Sorry, please let me know if you have any question. You can type or you can talk. Okay, so okay, this is experiment. There are 60,000 training image and 10,000 test image for 0 to 9. So let's see what the data looks like. Let me click visualize. Okay, so this is label is defines 0 to 9, and each column is about a pixel over there. The data set looks like is a grayscale. So it shows that each pixel stand for 0, just 0 and 1. Okay. But we need to ensure before we train the model, we need to ensure that all data sets are grayscale image. So I apply some code by using the Python over here to convert all opting to be the grayscale image. It means that there are only two colors, black and white. And then I train the model. I select the two model. First model I use the multi-class neural network, and the next one is CNN, stand for the convolution neural network. And once I done for this, we can see how the accuracy is. So okay, on the left side is a traditional neural network, and the right side is a CNN or convolution neural network. Someone heard that this is a deep learning. Yes, it's right. It's deep learning. We can use a deep learning over here. So you can see that the accuracy is better. For sure. Yes, it's better over here. Okay, and once we done this, we just select your preferred model over here and deploy to be the web service and class the web service workflow over here. And then once you done this, just deploy it as a web service as a similar way I show you on the last example. Okay, okay. This is API for OCR. application. You can see the JSON body for each pixel over here, and some example code. It's pretty long for the source code over here. Let's see, here we go. This is source code to guide how we can develop the application over here. All right. So the next one, once I done this, you can see that this is just only the API. But if we need to control about the policy or security over this API, so I have one more stuff. I mean that the Azure component, that is the API management. So you can use the API management and connect to the machine learning API, and you can define about the policy over here, policy and the security over here, to allow the developer in your organization to develop and connect the application over here. Okay, and once we done that, we can develop application like this. Okay, let's see at the source code a little bit. So I made the source code in two languages. It's very simple language like HTML and JavaScript. Okay, as a HTML is a presentation layer, it means this is an interface for the user, and this is a backend for the code. We need to put some data over here and send to the web service there. Once we done this, we deploy it over the app service or the Azure, and then let's see. Okay, this is an application. So we can write something over here, line number 3, and send. Oops, it's not good. Okay, well, try again. Okay, 3. Try 3. 1, 2. Yeah, it's number 3 right now. Okay. Okay, then number 1. Yeah, show number 1 over here. Okay, so this is a way how we can develop the Azure machine learning and deploy it as a web service and develop the application and connect to the API. Okay. So at this time, do you have any questions so far? Are you still with me? Hello. Okay, great. Okay, so the next one, I'd love to show you about one more cool stuff for the CNTK over here. CNTK or Microsoft Cognitive Toolkit looks okay. This is another view for the machine learning to make like a deep learning. You can apply the deep learning algorithm, and you can integrate the deep learning algorithm with the GPU or your GPU machine. So it means that you can customize not only the algorithm, but also you can customize about the infrastructure to train the model as well. So the thing that you can use for the algorithm here, that called Microsoft Cognitive Toolkit or CMTK. This is a framework and it's open source, so you can use this framework to put down in the model, and you can train the model on any infrastructure like on Windows and Linux. So there are many scenarios that we can use I mean that Microsoft are using right now. For first thing, Microsoft uses ATK for cognitive services. The second one is a Sky Translator. Cortana is a speech to text, and a Bing's search engine, and so on. The CNTK is open source, as I mentioned at the first time, and cross-platform. It means that you can use CNTK on both Windows and Linux, and even the OS X. And you can apply the CNTK over the deep neural network, or like a deep learning or something like this. And you know that deep learning is very popular. There are many tools. So we have some interesting comparison by comparing the CATK to the Author framework. I mean the Author deep learning framework. So this is benchmarking on a single server by HKBU, is a academic section in Hong Kong, and this is a comparison in terms of second per mini batch on GPU. Lower is better. So you can see CNTK plus with some framework like FCNA, RxNet, and so on. CNTK provide a better performance against like a TensorFlow over here, and the TOS as well. So okay, this is a pretty deep for the details. So I would love to show about the demo to get better understanding. Let's see what the demos looks like. So the first thing I like to show about the computer vision using the CNTK. I think this is very useful for the PNG. Once you can detect the image in the manufacturing, or you can, or even though you can detect for the customer loyalty, who you can detect who bought your product on the shelf, and so on. Okay, so first of all, you need to understand what about the definition for the computer vision. Okay, if we need classify the object, you can see that there is only one object in the one image. So if you use for classification, so it means you classify only one object in the one image. So this is a cat. But if you need to classify plus localization for one object in one image, this is a cat, and there's some square around the cat as well. If you need to make an object detection, so we can recognize how many cats over here, and where is cat, where is dog, and where is duck. And ideally we can make a instant segmentation what the cat shape, dog shape, and duck shape looks like by using the instant segmentation here. Fortunately, all of 4 scenarios we can use a CNTK over here. How we can do that? It's not too hard to do that, but I just need to show about the architecture first to get better understanding. This is quite different from the Azure machine learning component, since we need to use the CNTK under the virtual machine and some framework over there. So we call this data side virtual machine. So we put the CNTK over here. We pull the data from the many data source like DocumentDB or Cosmos DB and Azure box, storage box over here to pull the image and train the data over here. Once we done this, so we can deploy it as a web application over here. At the same time, we can deploy about the prediction result, and like someone like a business analyst can see about the how accuracy it is by prediction on this. Okay, let's see about the demo. Okay, you can see three mesh over here. So we need to detect the object inside. So okay, for example, I choose this one. And I send via the web application. Wait a moment. So let's see how CNTK works. CNTK can detect what it was in the refrigerator over here. Like this is orange juice, this is milk, this is ketchup, this is butter, and so on. Okay, this is a way we can apply the CNTK and train the model over the data side virtual machine and deploy it as a web application over here. Okay. Uh, for the resources that I show for three scenarios, you can take a look at the Cortana Intelligence Gallery at this URL. Okay. Uh, so if you have any questions, so please feel free to let me know. Hello? Yeah. Is there any questions so far? Okay, all right. So, okay. Please stay tuned for the next session on tomorrow. Okay. So, let's see. Today is my session for the Azure S1 AI. So tomorrow will be Ushwa who will deliver for the Microsoft Community Service. Yeah. Please stay tuned. Okay. So thank you so much for today and appreciate for your time for coming. So okay, let see you soon and thank you very much. Goodbye.